Hi guys, is there anyone here? I'll have to share the link somewhere. Same, I guess. I'm good, bro. So we want more viewers. I was able to finally make a Facebook account. Hi, I was able to finally make a Facebook account. So maybe I'll share screen or should I close WhatsApp first? Yeah, I'll close WhatsApp. I'll share screen. I'll share screen if more people joins. I'll try to see. Okay, we have 9 viewers. That's nice. I think I can share screen and try to see about Facebook Hacker Cup. Right? So Meta Hacker Cup 2025. I have done good in one round. In my this is my new Facebook account, but in the old Facebook account, I one time got 119 rank. Uh, I kept missing it later words, but then I'll show you my previous thing that I have done good. I think in 2023 I did good. 2023 round one, maybe 2023 round one. Let's see scoreboard. Let's see India. Where am I? My account has been removed. I don't know. Like I have done good. I think I got 119. I got here. I think here I got 119 rank, but then my account has been removed. Or was it round two? I have performed here, but then that account has been removed somehow. This is my new account now. I got 119 rank. I'll show it on my LinkedIn. Do you have viewers by then? Bro, questions are not like that difficult. They are like a bit okay only. I know how to go there. I have to go to my here. I have to go to my comments to prove my point. Recently, I have been commenting shit, but I have been commenting. Here I got it. Fuck, it's not there. I got here fourth rank in India. When was it? 2023 round two. But now I'm moved. It's fine. So let's try practice round and see quickly what it is. Okay. Do we have 10 viewers? Yeah, we have more than 10 viewers. I hope these people like the video. I have gotten 119 rank in round two. So the problems, don't worry about the difficulty of the problems, guys. You get scared unnecessarily, but the problems are all solvable. Like when I got 119 rank, they were solvable. I haven't used anything big when I got 119 rank. Once I got 119 rank, I'm telling it many times. Okay, let me try to solve the problems then. So how to upload results for practice means, okay, okay, let's try to submit them for practice. Chef Alfredo is catering his friend Benji's wedding and has end dishes that needs to be simultaneously go out at specific temperatures. Dish I has currently AI degrees and must reach a temperature of BI degrees, exactly BI degrees. AI, BI. While he has a fancy thermometer, he prefers to rely on his chef instincts to avoid constant measuring. Okay? His strategy is to repeatedly apply the following operation. Pick two dishes I and J of different temperatures and warm up the colder dish to match the temperature of the hotter dish. So we take two things. So what is the operation? We have to give more importance to our operation, right? Damn. Okay, right. Okay, this is really cool. CP algorithms is really cool. Right. So, first one, what is the operation that we can do? We have to focus on that well, right? We have to write the problem. Writing the problem down is not that easy. Uh, Take two dishes, Ti less than Tj, okay? Temperature of one less than temperature of that, and then what do? We make Ti equals to Tj. Okay, that means we make something smaller to something bigger. Okay, so what happens in this operation? uh, Something smaller becomes missing and something smaller can become something bigger. Okay, something smaller can become something bigger. That's the operation. Find a sequence of at most n operations or determine it's impossible. So now you have to think if this is the operation, when it is possible and when it is impossible. One thing you can say is max must match, right? In AI comma BI, in A comma B, max should be matching. Whatever happens, max should match. Otherwise, it's no minus one. Otherwise, one, two, three, right? Okay, but is that stuff? Is that enough? What you have to do is what you have to do is make all A things into B's. Okay, so you have few A things. So let's say C is common. Okay, C is common. Now you have few A things and you have remaining B things. Okay. We have few A things, we have remaining B things. So now what? If you try to see from these few A things, let's look at this set. Okay. This set, these few A things, they are not in B at all. You have these few A things. Let's say some are common already matching. You have these few things. Okay, some are already matching, some are not matching. Okay, whatever is not matching, can you make that? So let's, okay, some are already matching. Let's make it even simpler. Some indices already match, some don't, right? So let's look at indices that don't match. Okay, let's look at these indices that don't match. Let's look at highest index that don't match, like whatever the index that don't match with the highest value. Okay, that should be these are all sus. I should not be doing. I was just explaining few things to my friends. Bro, I cannot do this itself. I'm struggling. I somehow made some time. CSCS is for you to do. Just you try yourself. So some don't, right? So what can we say? If you look at highest index, highest temperature, that's not matching. Okay, this must match to, like, I mean, its BI must already be present. Okay, this statement you can always say. Why? If that BI is not present, then you cannot make that, right? Because this is the highest temperature you have. Why am I talking about highest temperature? Because if you talk about lower temperature, maybe it's not there right now. Maybe it will be formed later, right? But then if this is the highest temperature that hasn't been formed yet, okay, this is the highest temperature that hasn't been formed, that should be there, right? In no other way you can get that. What I mean is that should be already there in A. Then you, why, if that is not there in A, you cannot make this thing into that, right? So, so if you sort in terms of temperature, okay, whenever it doesn't match, okay, let's say for I, AI not equals to BI, then BI must be something, must be equal to BJ, J greater than I. So this is the condition. If this satisfies, we are done. I was trying to see from the biggest index I in here, like whatever the biggest index I we have to see there, and then we have to come before, and then we have to come before. But then we can even make it like that. We can even make it like this. If this happens, this implies and implies it's impossible. Okay, implies and implies it's impossible. Else it's possible. So how difficult it is? It's not that it's guessable. It's guessable. Is this clear, guys, or is it a bad explanation? I think it's bad. It's bad explanation. So let's see about setup. Okay, let's see about setup. I also don't know much. So, but is this clear? Like for a solution, sort in terms of temperature. Whenever AI not equals to bi, AI not equals to bi. Now it should become something bigger, right? So this bi should be equals to something bigger, right? Can it become smaller and then try to become bigger? No, that's not possible. You draw a line, okay. If it's becoming smaller, it will be right here itself. If it has to become bigger, nah. Sometimes applying logic is not that easy. I don't know. It should be easy. I can do this, I guess. I think this is enough. Yeah, because AI will become a BJ anyway, right? Yeah, that seemed unnecessarily not that intuitive, but then final values of AI will be uh, equals to bj, right? So what I'm trying to say is, let's come from right side. Let's come from right side. That thing must become, because that's the biggest thing that is there. It can only become something bigger, right? It cannot become smaller. It can only become something bigger. So then that must be equals to this thing. That holds true. And then now this will become bi, and then you have to apply the same thing. So it's actually, because AI keeps changing, right? BI is fixed thing. So writing in terms of BI is correct. If you come from right side, you can see for the first AI not equals to BI, it should be equals to some BJ greater than that. Okay. Now this AI is become that AI will become BI. So now we are again going to something smaller. So if this satisfies for everything, then we are good. Is that fine? So coming from that side is better. We have to sort them. So how can we do it simply? Int n scene n, let's say, okay. Vector int a of n, let's say, okay. I will sort them based on bi's temperature or ai's temperature. I think I will sort them based on bi's temperature. Why? If some, I think sorting based on bi temperature is fine. We can apply the same logic. You have sorted based on bi's temperature. Why? Because if some AI is less than, is greater than bi, is greater than bi, it's impossible. It's impossible. If some AI is greater than bi, it's impossible, right? I think just this works. Not sort based on bi, because we are seeing more bi values, right? I mean, this seems counterintuitive. Not intuitive, like, I mean, I'm just doing something mathematical, let's say, okay? Because these are implies and implies. If this happens, you have a way. If you have a way, then this also must happen, right? If you're coming from right side. But what is our argument again? If I'm coming from right side, let's say I'm sorted based on B. Coming from right side, these both were not equal. Okay, there can be some bigger A here. But if there is a bigger A here, okay, then it's again it's failing this itself, right? It's failing this itself. So sorting based on BI is fine because BI are the value that we go to finally. Okay, try to understand a bit. Like the thing is, that's why logic is coming into picture. If you want to build based on logic than intuition, intuition is the worst term I hear like from people. I don't like the term intuition. Okay, it's not intuition. You have to solve the problem logically. Okay, there is no intuition here. Okay, I don't like intuition term at all. Somehow, really. Mm, yeah, that should be enough. Yeah, that should be enough. That's the same thing as this. Uh, but how do we say that? Okay, it's in B, right? Then where do we go? We go to the highest B that's not there first. Highest AI. Yeah, both are same thing. Okay, even if you don't sort and if you apply whatever this guy has told, AI not equals to BI. Okay, leave sorted. Okay, even leave sorting, and AI must be present in B. This is enough. This is see. This is necessary condition. This is a necessary condition. Okay, why? If it is not in B, if sorry, bro. Okay, I don't know what you mean. Leave. Like I think you have spoiled it a bit. Like I got confused. Sort it based on B. Okay. What am I doing is I'll sort based on B and then I'll apply this logic and then that's enough because if A is greater than BI, it's anyway impossible. Okay. If A is greater than BI, it's impossible. You cannot go back and then take help and then become bigger. Okay. I think you have to sort based on there are some tricky cases here, really tricky cases. What? Let's say BB matched. This is same value and then this is B1 bigger, B1 bigger, let's say B2 bigger, B2 bigger. Okay. If I keep it like that, I will think that A cannot match to B if I'm coming from right side. But then if it is AB B1 B2, BB B1 B2, then I can see here, okay, yeah, A is not matching to B, but then A can become like that. So also A should be in increasing, also first B should be in increasing and then A should be in increasing. Maybe A increasing and then B increasing also works. Maybe that also works because we can only become bigger things in terms of A, right? So both A increasing, B increasing works or B increasing, A increasing works. B increasing, A increasing is very difficult to think of, but then I saw that like even B increasing, A increasing works. I think anything works. I will try B increasing, A increasing because it was not that intuitive, right? So we are keeping B first here. So I am giving B increasing, A increasing, and I think still it works. What are the values? So this question is not that easy. Okay, values are within n itself. Okay, values are within n. So instead of set, I will use came. Vector int came of n plus 1 comma 0. For int I equals to n minus 1 I greater than 0 I minus minus. Okay. Let's collect answers. Vector pair answers. Okay. If a of I not equals to b of I and came of b of I equals to 0, return c out minus 1. Return. Okay, done. Else, what should we do? Else, what should we do? We have to update answer with I comma came of b of I, let's say. And then what should we do? Came of b of I equals to I. I think it became messy. Yeah, this seems simpler, right? So if ai not equals to bi, if the bi hasn't occurred at all, then it's minus 1. Else it is we are pushing that I comma came of b of I. Came of b of I will have that index which has already became that, right? One based index, that's why I'm doing that. So now we run the test case and see if there is any error. I'm sorting first B and then first A. Okay. So we have 0 2, we have 2 3 1 2. It might work. I'm taking. Nah. See, AI will do these things easy. Maybe they are making things AI type. See, this is the index, right? This is the index. We are jumbling them. I'll just keep it plus 1 then. And then I can remove these plus ones. Because index is separated. Or I will keep plus 1 here itself. Because the index is anyway separated. Seems fine, right? 0 2 2 3 1 2. So I'm making 2 to 3 1 to 2. Seems fine. I'm telling case 3 as minus 1. So we came here. We can make it 4. Oh, we can first make this 3. It's gone. I'm doing everything wrong. I don't know why. So this could have been this, and then it could have been this. So I'm wrong. So this, I think maybe we can. So our proof was also wrong somewhere, right? What was our proof? These were necessary, but then maybe they are not sufficient. I'm sleepy. Okay, let's write better condition. Okay, greater than or equals to AI. BI should be equals to something greater than or equals to AI. I think this seems fine, not BI. Okay, my BI. Okay, this is bad. I think someone told me sort based on AI, then that seems correct. Sort based on AI. Now, if BI should be equals to some AJ, J greater than I. I think this is fine. Sort based on I, sort based on AI. This seems fine. This is very clear. Why? Now, I don't know what I have done. Sort based on AI, this can become something this. That's the problem, right? This can become something this itself, right? So you have sorted, this can become something this can become something this can become something this. So you have to come from this side because coming from this side is better. You have to come from this side. If this can become something over this, then we are good. So for every AI, if this is happening, we are good. Okay. This can become something equals to this, we are good. And then we have to do operations from this side. We have to do operations from this side. Let's find the answer from this side and then reverse them so that answers will be like that. Okay. I have to sort based on A. That's very clear to sort based on A. Okay. These are just finding answers. Now I'm just trying to find the answer. Okay. I'll just keep came off. See, I'm just trying to find this as the answer. BI should be. I'm trying to find these answers, but then we have to do them from this side. Why? That AI might have gone right. We have to. If we do this from this side, we are good. We are all good. So this is clearly proved. This is a necessary condition. This this is necessary. Why? AI can only become something, some AJ greater than or equals greater than AI, right? This is it cannot become anything else. So bi must be equals to that. This is necessary. And is that sufficient? It's sufficient. It's also sufficient. Sorry, it's a simple problem. It's again coming from operation directly. Operation says ti less than tj. Sort based on a. This can only become that. That means this can become some of AI things, right? Means this sort based on AI, if this is not equals to, if this is changing, if this is changing, this can only become something bigger, right? Or stays the same. It can only be some, if it is changing, it can only become bigger. Means BI must be equals to some AJ greater than AI. And if that is happening for all the non-matching things, then you can go and select the first thing, change it to that AI, done, and then go to the next thing, changing to that AI, done. This is necessary and sufficient. So this proof is clear. I don't know what I and simple. See, we have to follow golden rules. They are always simple proofs. So if it is there, this IDX should go with that value. But then we have to reverse these operations, okay? Because we have to first come from starting. So now what are we doing? 1 comma 2. I'm making 1 as okay. AI is 0 BI when I change that, right? Fuck it. I'm ending the stream, guys. It's being too bad. AI, BI, if it has came. Okay, why is it failing for this one? It says -1. Why? One is not matching to that. Okay, one is not matching to that, but then one is matching to two, right? Okay, came of BI. I don't know why I changed that. The BI should have already occurred. Here came of A of IDX is correct. So one is changing to three, two is changing to three. Okay, fine. See, this seems correct. This should be correct for everything. So after struggling a lot, I think we have solved the problem, right? So now we have to change this thing. So we are done. Now what? Now what should we do? That's an easy problem. I don't know why I have done that. Submit for practice. Let's try to click that. Scary. What should we do? Upload the output file produced upon running your code on the full input that you downloaded as well as your source code. So now we have to see. No, there is something simple that people do. Okay, this seems simpler, right? So let's try with that. All we have to do is read from a file, right? So we have a downloaded thing. I copied that. I'll paste it here. I didn't even make a new folder. Should I try to make a new folder? Okay, I'll also copy this file. 1058 div1, right? I'll copy that file too that we made, paste it here, and then I'll close this. So okay, we have this, we have that. Let's rename it to just input.txt. Okay, let's try to run this thing. G++ a warm up dot cpp, right? This is happening because mine is C++11. I don't know, it's C++11, G++20, G++. How to run a better command? This thing is happening because C++11 it is. Guys, anyone know how to update VS Code to C++, bigger C++? See, it's not about timing in and timing. See, input and output is done. This is something else. This is like my vector representation is not allowing me to do this. My vector representation is not allowing me to do this. See, it's some C++12. Fine, if it not allows that a of I dot pushback of x, a of I dot pushback of 0, a of I dot pushback of I plus 1. And if it says you have to keep this shit here, let's keep that too. And then what? What about this? Done. Now we have to run it. We're getting segmentation fault. But we got output.txt. 87 cases. What is this 500? Okay, my laptop, I'm using work laptop by creating a new. How to increase stack? How to increase stack? That's it, guys. Now let's just check it. Okay, now we have big answer. So it's not that difficult, I guess. This means it's not that difficult. So now let's go and upload. I think I have to comment these things. Accepted. But there will be more, right? There will be something like some code you will get, and then you have to use that code. He came from behind. Rainboy. Guys, I'm scared of B. So let me read B. See, A we have I have overcomplicated. Yes can become only yes. Some A will become this A. That gives you obvious necessary condition that whatever the BI it is becoming should be here. And that was enough. Just the ordering should be from this side is the only extra thing. I don't know why I complicated it, okay? So we are not getting the right experience then. Maybe we will panic in the next real contest. Right. Nice bro, 154 rank is good now. So let's try to read B. When you use MetaQuest, you set up a guardian boundary as a safe zone for you to move around within VR. You're trying to figure out the size of the largest guardian boundary that you can make inside your house. Your house is represented as an outcross C grid surrounded by a wall on each side, where each cell is either dot or representing an empty cell or representing an object. To ensure that you don't hit anything while playing, you want to find the largest contiguous space in your house such that every cell is at least S spaces between itself and the nearest object or wall, such that every cell is at least S spaces between itself and the nearest object or wall. How is wall described here? Formally, the shortest path from a safe zone cell to the nearest object or wall must visit S or more spaces, not including the start and end cells. What are spaces? Empty space. Okay, yeah. So for a safe cell, o- object or wall should be very far, it seems. Okay. S is less than or equals to 1,000. What should we find? What should we find? Size of the largest guardian boundary. What is a guardian boundary? A safe zone for you to move around within VR. And where can we move? So let's see. Okay, this is the case one, right? S is equals to 1. Means all these are safe, it seems. So that's why we have answer to be 9. Okay. What about here? Based on s equals to 1, all these are fine it seems. Now what? Now is this the answer? The connected component, is that the answer? 5 plus 3 plus 1. Sum of odd squares is 16, right? No. 5 plus, maybe 5 plus 3 plus 1 is 9. 3 squares. Sum of odd numbers is some odd number square, maybe. I don't know. 9. So is the answer 9 again here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is also connected. 10. So it's like connected components. See, first step is, so it seems to be, so we have safe cell, okay, which is not as close to any object or wall. Okay, this is a safe cell. Now it's just connect maximum connected component, biggest connected component of safe cells. So this seems till here it seems fine, right? So is this the problem? First we have to find for all cells this value and then we have to find that. If you see here, we have 70 test cases. For each of them S is less than or equals to this, but then R into C is very big. S is less than or equals to this. Okay. Now how do we do that? See? So checking with wall is easy. Right. Means what? What does this mean? Up, down, left, or right, right? So Manhattan distance. Somehow Manhattan distance would be like this, I guess, right? If you are here, all these things, all these things, all these things, all these things, or all these things, you have to say within this thing, if there is a object or not. If you can answer that, then you know if this is safe or not, right? This size is not that big. One thing is this thing should be within wall. That's the first thing. And then you should see if there is no this or not within this thing. If you can somehow maintain prefix sums for all the all the diagonals, maybe then you can do that. Maybe then you can find that. But isn't this complex? Like first step is definitely finding if a cell is safe or not. Okay. The problem logically doesn't seem, yeah, you have to try C++ and then keep submitting answers. It's whenever I mess up, I won't be using them, bro. I cannot use them well. That's why I kept them as rules, right? If I can use them well, I would have been much higher rated, bro. I cannot use them. It's not that easy. Okay, but for this now, how? Is there something simpler that I can do? This is 1000. We have to say if there is a black cell within this or not. Okay, for that it's simple. It's simple. You take this one for this black cell. Okay, we have to represent this, right? All these things has some x plus 5 value. All these things has some, I like this solution, so I'll go ahead with that. You need not do some prefix sums or anything. If you are here, if you know this x plus 5 of these values for these things, if you know x plus 5, see these diagonals are all same x plus 5 values. If you notice, if you give them like 0 comma 1, 0 1 2 3, 0 1 2 3, x comma y, all this has same x plus 5, all these has same x plus 5. So when you're here, for all of this, if you have this x plus 5 or x minus 5, you can know this minus this minimum distance, okay? And then you can also know this minus this minimum distance from for these things, okay? And then you can also know for this x plus 5 or x minus 5, y minus x. For this also you can know x plus 5 or x minus 5. And if you have all of them, you can check very quickly if something is within this or not. So is this clear, guys? So this seems simpler, right? I don't know. I don't think we can use BFS, right? Why complexities doesn't seem doesn't is not allowing us, right? Like, see, we have 10 power 6 cells. You cannot do 10 power 6 again. You have R cross C. So if you know just x plus 5 value, then you can know whatever is the minimum thing on this side. Okay, in this segment, whatever is the minimum thing, like in this side, whatever the minimum distance would be, can be represented like that. Okay, how far is it on that? Why you have to go like this and like this, right? You have to go this, both are positives, so it's x plus 5 minus x minus 5. And then you for this, from this side you want x minus 5, from this side you want the other thing, from this side you want the other thing. And if you have that minimum value of that things over this thing, then you are good. Or you can have all x plus 5's, all x plus 5's. Okay, then what would you do? You will try to see the lower bound of this. Okay, the lower bound of this if it is greater than s, or lower bound of this if it is less than s. Okay, even that works. Do you see what I mean? You can just have that lower bound. You can, if these values are in a in a set, okay, you have some x plus 5 values. You are here now. You have to just check if it is within s or not, and you have to check within this thing if it is within s or not. So this is a simple solution, right? You have x plus 5 values, you have x minus 5 values. For both, you will try to check if this is valid or not. This is O of log n. We need not do BFS. This seems clear, right? This seems fine, right? Set is enough. Lower bound works. Set is enough. Now the solution is clear. I'll just implement it now quickly. Sorry, I was distracted a bit. See, Manhattan distance is x plus 5 minus x plus 5, okay? So what do I do? Int vector. I think I'll just use int of n of n plus 1 n plus 1 for int I equals to, I'll initialize it to 0. See, solutions can always be simplified. I will keep safe things as 1, okay? safe is 1. So our walls are also 0, right? Now I will maintain a vector, not even set. But set is also fine, vector is also fine. Vector int x plus 5, x minus 5. Okay. Of unsafe cells. Okay, if a of I of j equals to 0, that means it's unsafe, right? So I'll add that x plus 5 dot pushback of I plus j, x minus y dot pushback of I minus j. Okay. Now int safe of n plus 1 n plus 1. Okay. I'll write it here. I'll copy paste this thing again. I'll initialize safe to 0. Okay. I'll again copy paste this thing. And then what do I do? If a of I of j equals to is not equals to 0, and so okay, now we have this. So now our xy, now our plus is I plus j, our minus is I minus j, right? The same thing we are using. How to check if adjacent things to p are closer than s or not? This we have to check. Guys, this solution is wrong. The solution is wrong because you cannot just put them in an array and then you can check them. You cannot just put them in an array because if it was here, you don't know the x plus y, right? X plus y could have been matching, but then the x minus y won't be matching. You have to do this. You have to do this prefix minimum over all this. You have to do that prefix minimum over all that. You want prefix minimum over all these things for x plus 5. You want prefix maximum over all these things for x plus 5. All these things are not good. See, we must do those prefix minimum, prefix maximums. I won't be solving this problem. Can we do BFS? That is correct, but then BFS complexity is not good for us, right? BFS we can do, but then how can complexity match? Because S is less than or equals to 1000, but still nah, right? Let me go to C. Okay. So guys, do you agree with the prefix min means like for this segment I want, right? If I look from this side, it's like some prefixes and then prefixes of prefixes, right? That's what I mean. So we want that minimum. That seems not that easy. right? Or we have to keep coming like this, keep coming like this, keep coming like, I don't know. So it got accepted with BFS. But then how can we say about the complexity? Okay, okay. You can do BFS from, okay, I see this. We can do BFS from multiple sources, right? Okay, we can do BFS from multiple sources. That is also there. Okay, we can do BFS from multiple sources. So, not, I mean, multiple sources means all of them are bad, right? Okay, all of them are bad. From them, if you do BFS, and then you can just eliminate the other things. Yeah, that's a nice solution. That also we can do. So to find safe things, also you can do BFS. Safe things, you can do BFS. See, what do I mean by multiple sources is you have many things, right? Just imagine that from all the objects, you have one more node, S, which is at zero distance. Now, if you try to find BFS from here, because this is zero, it goes directly to here, and then from here it will check if uh, something is within this distance or not. So that's it. You means you take that all of these are zero. You take all the walls zero, this one zero, and then you do BFS, because this prefix idea many people cannot use that easily, right? Like four prefixes is bad. So this is the solution that anyone will do. Two BFSs, like keep all these distances as zero, and then start doing BFS. Like you have inserted all these things into Q as zero. Now you try to find all the ones adjacent to all of these things. Okay, adjacent to all of these things. BFS is, so now you have next layer. You have all the ones. From there you find all the twos. From there you have many zeros. From zeros you try to find ones by trying to check the adjacent ones. So that seems fine. BFS is fine. So should I implement that? Because I cannot go bad on implementations, right? So yeah, I'll just implement that. It's fine. So we should do BFS, right? And then we determine if something is safe or not. So int dist of n plus 2 comma n plus 2. So this will have all the distances. Okay. I'll keep the distances here itself. Okay. Int used of n plus 2 of n plus 2. Okay. I'll just use this drx of 4 equals to 0 1 0 minus 1 0, int dry of 4 equals to 1 0 0 minus 1. Okay, just to go over adjacent things. Can I use two BFSs as a function? I need not do that. I'll just do normal BFS multiple times. Okay, let's say this is initialization. Initially everything is same component, right? Q pair int comma int s q. Okay, I'm trying to do the q thing. Distance of I of j equals to 0, let's say. Just make it like n into m plus 1, or something. If a of I of j equals to 0, means it's a wall, right? We are pushing walls. Okay, so now we have pushed walls. While not q dot empty of def equals to q dot friend of q dot pop of int x equals to f dot first, y equals to f dot second, and then for int I equals to 0 I less than 4 I plus plus int dx equals to drx of I dy equals to dr y of I. Okay, and like let's say new x equals to x plus dx, new y equals to x y plus dy. I just keep bool okay. Within the cells. Okay, if okay of nx comma n comma m comma nx comma ny, what do I do? And not used of. This is just BFS. So now we are done. Safe equals to disk less than or equals to s. Disk greater than s. Right. Safe equals to distance greater than s. Yeah, you can try everything, bro. You can try hacker rank, you can try lead code, you can try code forces, everything. This is not a good problem. But yeah, so yeah, we have this, we have safe vertices now. So now what should I do? Again, something similar, right? I'll make them. Now we don't care about distance, but we only care about used being zero. Okay. Now I don't care about distance, but I'll just make use of I of j equals to zero. So now, okay, now we will again try to do DFS. Okay. If not safe of I of j, if not safe means so now we are at a safe vertex. Okay. I push I comma j, I make use of I comma j equals to 1. I'll do same. Int size equals to 0. Int answer equals to 0. While not q dot empty of. Okay, I'll try to copy paste this thing. and safe of an X and NY. It should also be safe. This should be not used. So many errors. So we pop things only once, right? Once you pop, you can do size plus plus. Answer equals to max of answer comma size. Okay. You can copy paste this part onto here. We can run and see whatever goes wrong and whatever stays correct. Only one compilation error. Oh wait, paused. So let's try to submit this thing then. See, implementations don't take time, much time at least. Should we do the stack thing again? Mhm. Mhm. Maybe that's the only error. That's what I'm trying to ask you. Why did I get this at fault? Yeah, they are good, but then you have to try many more problems, bro. You have to try a lot. You cannot take things easy, okay? Try pattern, try every problem, bro. Read so many problems. Don't slack, okay? No, this tax space. Does this tax space is this tax space wrong? We cannot do that. We cannot keep them. Because someone was trying to help me before. Someone told me to see something. I think it's my error. Like I'm making some error here. Right. Does online compiler give us enough stack? No, right? Fuck it. Let me read C, guys. It's time waste for us. Code monkeys love permutations. A group of metamates, have approached you with a curious array of length n that they have created with a special process. They started out with an empty 2D array of B of permutations and repeatedly performed one of the following operations. Choose an integer key. Okay, this seems a nice problem. We have permutations. Okay, they started out with an empty 2D array B of permutations and repeatedly performed one of the following operations. So we have empty 2D array B of permutations. Okay, choose an integer k and append the identity permutation to the end of B. Choose an integer k and append. We are appending an identity permutation for each permutation in B. What the fuck is that sound behind? Rotate all elements to the left by one index. For each permutation in here, you rotate all of them by one index leftwards, it seems. So for each p equals to this, they become this. Okay. Finally, the array A was constructed by flattening B. For example, if this, okay, to study this code monkeys, you will need to backtrace the steps. In particular, you would like to find any sequence of operations the monkeys could have performed to construct A using at most 2n operations. Okay, this seems simple and nice problem, right? This is definitely better than B and A because this doesn't use topics, right? This just use some logic. You should be able to divide them into one 2k numbers, one 2k numbers, one 2k numbers, and say that they also work out. Okay, and say that they also work out with respect to the cyclic shifts. Should we show if it is impossible or it will always be possible? So that's what they have done. Means there is like at least one way is there. Okay, at least one way is there. If you see here, at least one way is there. You are given A, you have to find the B and the operations that were performed. Okay. Sometimes we append, and then we rotate sometimes. Okay. So do you guys get it now? Yeah, yeah. No, maybe there is some bug. Maybe there is some n comma m bug. We don't know, right? Maybe it's my fault. There is some n comma y bug or some other bug. Because we had many bugs. Like when I was typing it, there were many bugs all the time. But yeah, keeping that aside, we have to solve this problem. This is a good problem. Do you guys agree that this is a better problem? Logically, you can work something on this problem, right? You will get scared. You will get scared because it is using permutations. It is, but it's like you have to retrieve it back. You have to use logic here, right? Okay. So we have to split it into permutations. Writing problem statement is you have a process of making A, you have A, you need B, and the shifts possible. Okay. Size of A is n. Size of A is n. You can do 2n operations. Okay. Are we done if we just split them into permutations? Are we done with just this? Think of that. Think of that. I think that's it, done. If you just split them into, this is necessary and this is sufficient. Why? Why? Uh, nah, 1 minute. Permutations, who are that match cyclically to A. To identity. See, because we cannot have any kind of permutations, right? We should have permutations that are cyclic permutations, like 1, 2, 3. Like you can only shift that. You cannot have any other permutation. So you should be able to split permutations that match cyclically. Okay. So you should be able to do this. And if you do this, that's enough. If you can do this, that's enough. You need not worry about them matching perfectly. Why? You can come from behind and do cyclic shifts on lost permutation. Okay, this will affect this will affect all the previous ones, but you know the offset, right? You know the offset. This is just of len of permutation, which is less than or equals to n. So do you guys agree that cyclic shifts are not a problem? Just splitting is enough. If you can split them into cyclically matching ones, then you are good. Then you are done. That's it. You should just split them into cyclically matching ones. So do you guys get this one? You have to take time, bro. Wait, what happened? Okay, how to close this thing now? Yeah. So what happened? So do you guys get what I mean? See, you need not worry about them being rotated, right? If you can split them like this, you can come from the lost permutation and then you can adjust that thing. Now you know how all of them have been altered. Okay. So now you can do cyclic shifts to again fix this. Now you can add cyclic shifts to fix this. So is this clear, guys? See, if you can split them into just cyclic permutations, then you can do the cushion. Done. It's not difficult. It's like it's just trying to scare you, but then it's not at all difficult, right? So now how can you split them into cyclic permutations? What are cyclic permutations? Okay, you have 1, 2, 3 up to so on k, right? And then you have 2, 3 up to so on k, and then it's like r plus 1 up to so on, and then you have 2. You have 1, 2 up to so on r minus 1. Okay, so you're able to see like this is the start. Let's say if it is starting from r, you have to go and find the r minus 1. That's it. Then you have that cyclic permutation, right? Why? If it is starting from r, but then if it is starting from 1, then you don't know, or greater than 1. If it is starting from 1 up to so on, okay, this r, this k could have been coming from somewhere else. 1, 2 up to so on k minus 1. But still, you can merge these things and then you can treat this as a separate permutation. Do you get what I mean? See, this thing was this thing was everything that is demanding in this contest. if you're going to do it well or not. In this contest, I have done F1, but then I have done F2 too. See, in these cyclic shifts, we have that 1 to n. We have this 1 to here, but then you should not confuse. It could have been coming from like this or like that, or like this and then like this. Here it is important to differentiate them, but here it's not important because here all we need is some cyclic permutations, right? Even if you split them like this, it's cyclic. So yeah, if it is 1, go as far as you can. Okay, if it is 1, go as far as you can until next one. Okay, if it is r, go until r minus 1. In this way you can split into cyclic permutations, and if you can split into cyclic permutations, you know how to insert two operations in between, right? Do you guys get what I mean? So what? See, for splitting the algorithm is just this. If it is r, go till find r minus 1. If it is 1, go till find till as long as you can go. Okay, if it is 1, try to go as long as you can go. Because even if it was ending here and the next permutation was this, try to go till 1. Because if the next permutation is this, even then you can make it like this and this, right? So that's working. You can make it like this and this. So go until 1. If it is r, go until r minus 1. Now, in this case, what's the shift? Shift is r minus 1 times. Why? If you do once, 1 will go here. And then all of them went here. Means shift is r minus 1 times. Okay. Here shift is 0. So for all, find the shift and find the split and shifts. Okay, simple algorithm. For r, try to find r minus 1. For 1, try to find this simple algorithm, and then you have splits and then you have shifts. So we are going until the next one comes or the array ends. Okay, now we have this permutation, right? Here what should we do? We have to go until, we will definitely have r minus 1 here. Okay, because if it is r, there definitely will be an r minus 1. Okay, okay, len equals to j minus I right now. J minus I is the length of the permutation. Okay, and shift equals to shift comma len, let's say. Shift equals to r minus 1. Okay, len equals to this. All we want is lengths comma shifts, right? len comma shift. All we want is this. Okay. Now we find the operations. Okay. We come from behind. Or should I just reverse it? See, every shift you apply to the last one, the previous ones also will get applied, right? I'll just reverse it. So, int extra shift equals to 0. We do some extra shifts, right? Initially it's 0. Okay. Int len equals to f dot first, shift equals to f dot second, right? But already extra shifts are being done. So we have to do this shift, but then extra shift is being done. So what is left? What is left? You should do this. You have done that. So what is left? How many shifts you have to do now? How many shifts you have to do? In shift need equals to, you have to achieve this. But then this was done. Okay. Take reminder with len and then add len. Okay. And then maybe make it again. Done. This is a very simple idea, right? See, why is it extra shift? You are coming from behind, right? Whatever the shifts that have been applied to here, also they have been applied to this. Finally, so you have to negate them. Means how many shifts you have to apply here now? You have to apply these many number of shifts so that the total shifts will become shift. Extra shift plus shift need will become shift. Simple. So these many you have to do. So what do you do to operation? So what do you do to operations? We'll just keep adding 2 comma 0, let's say. Okay. uh, for int I equals to 0, I less than shift need I plus plus, you add operation dot, it's 2 comma 0. 0 is not needed. See, whenever it is 2, we need not add one more thing. That's why I'm just keeping it 0. I never used make pair. I never used make pair. Why did it not work? Why the fuck it's not working? Okay, now what? We should also form this array, right? 1 comma len. So because it's reverse order, first I'm doing this and then I'm doing this. Okay, now we can just reverse op and then just output it. So then that's it, we are done with this. There can be multiple answers. 1 comma 0. I equals to j minus 1. Okay, you found r minus 1 here, but then you have to do plus plus. Why? R minus 1 is also included, right? Here until 1. So guys, this question is solved. Okay, it's not getting accepted. I'm having some bad luck, let's say. Okay, a of j not equals to 1. That's because it's going into infinite loop. So now what happened here? We're doing two operations, it seems. One operation is this, the other one operation is this. See, 1 comma 5 2 1 comma 5 1 comma 2. Nah, this needs a shift, right? Okay, this is wrong. While a of j is equals to a of j minus 1 plus 1, because sometimes it may appear wrong. As long as it's extending, not as long as 1 comes, till here you can do that. And then you're at a j where it's not equal. Okay. In this case, you can go till r minus 1. So yeah, now we are doing two twos. Perfect. Two twos will make this correct. So this seems correct, right? So now let's try to see if we can submit this thing or not. Okay. Or we have viewers. No, that's wrong. If one, we have to go till as long as it increases. Okay. Like the video, guys. Mikoyan, it's not difficult. You have to make things easy for yourself. Don't tell lies before telling them very clearly. It's not easy to improve to my level, right? I've been doing it for 5 years. You're fine with split, right? So let's see if this one will get accepted. But this problem is a better problem when compared to B, right? Simple, like there is nothing here. Like I don't even feel good for this problem. This anyone can guess. Shifts we know. It's just the fact that these things will affect them. Once you know this, you can know what's their effect and you can judge what this should be. And then you can keep going. It's done. So let's try to see if you can submit. So now we will know if our stack was the issue or not. It's done. What happened? Did it right or not? Okay, with these two things, why is it not writing? It's not writing into output. Why? Any idea how we can? Is it stack? At least this should come, right? Okay, I'm doing written, I guess, somewhere. What is bus error now? When this is failing. If I'm written here also, it's failing. Why? Even this is failing. This one has passed before, right? Yeah, that is passing. Wait, this answer is wrong, right? This answer is wrong, right? Let me output shifts and see. 1 1. That is correct. So after 1, okay, extra shift I'm not updating. Okay, now this is a correct solution. Okay, why is it showing warnings before error? Like, why is it showing warnings before errors? Thanks, someone, whoever has told me that. Bro, the C++11, who uses C++11? I, okay, done. Finally. I think I do better in the real contest, probably because of all this, right? It's fully correct. So yeah, that was also good. That was easy. That doesn't has any logic, right? It was direct. That doesn't has any logic. Like it was direct. You split them. I mean that I don't even feel good about that. So let's try this one. Teddy, the tech lead, is planning an outing for her team of encoders. There will be M fun outdoor activities distributed over 2 days with the following requirements. Each day must be scheduled on either day when each activity. So we have M activities. Each of them should be on either day one or day two. It seems each activity has exactly two distinct participants, coders AI, comma BI. So each activity has two people. Each activity can be either here or here. No pain. See, when there are more things on the problem, you have to be happy that you can work something. The difficulty is not because of some topic or something, but the difficulty is because you have to solve the problem. No pair of coders is involved in more than one activity. Means no pair means like you can see them as edges. Like one pair comes once, a pair doesn't come twice. So there are some pairs. Okay, there are some M pairs, and for each pair you have a day. Till now that's what it told. Okay, there are some encoders, there are some pairs, you can see them as edges. It's a simple graph, I think, because there are no multiple edges. On each day, the total cost that any given coder incurs on that day is the square of the number of activities they do in that day. Okay, this says something. So the cost is sum of squares of number of events activities he does, it seems. Okay, cost of that day. The total cost of the outing is sum of costs on both days. Please help find any assignment of. Okay, this is a good problem, right? This is a good problem. We have n edges, n nodes. We have m edges. Like it's there are no additional constraints. Okay. So guys, do you guys agree that this is a good problem? See, you have m edges. You have to split the edges into day one and day two, such a way that after you split the edges, summation of this guy's degree whole square plus summation of people's degree whole square here in these two graphs, that should be minimized. This is the problem. Do you guys get, like, we have a very concrete clear problem now, and that means there is a simple solution to this problem, and you will solve that problem. Okay, means you know what you have to exactly. Yeah, you know what you have to do. Find, I mean, it's not that good. I mean, it's like very simple is what I mean. Till now it's very simple. You have to split them into two graphs. You have to split edges into green and red edges. So now we have two graphs. In this graph, you will find all degrees and you take summation squares of all degrees. In this graph, you take squares of all degrees, and then you have to get minimum value of this. You have to assign red and green such a way that this will become minimum, it seems. So how can you do that? Because graph is very general, right? Graph is very general. What greedy can you say? You have to think a bit. You can also think one thing. What happens when you move a red edge into a green edge? What happens? If you move a red edge into a green edge, here two things will become minus 1 whole square. Here two things will become plus 1 whole square, right? They have given us. Wait a minute. We have to assign them into each days images they have given us. See, they don't appear. We have to assign each edge into green or red color. That's what we have to do. See, green or red color for each edge. So now we have to think of the problem. Like, is there anything greedy we can do? Like, for greedy, what I'm trying to do is, if you move red edge to green edge, what happens? Minus 1 whole square, plus 1 whole square. That's the difference, right? That is the difference, right? In terms of degrees. Yeah, yeah. So minus 1 plus 1. Can you say anything? Like you cannot have an edge among two people. Okay, let's say you have an edge. Okay, you move -1 to here. What happens like for some guy? For some guy, if you try to simplify it a bit, uh, so if you move an edge from green to red, it will become x minus 1 whole square here, x1 minus 1 whole square here, plus x2 minus 1 whole square here, plus x y1 plus 1 whole square here, plus y2 plus 1 whole square here, right? But we know that x1 plus y1 is fixed. Let's say d1, degree of some guy named 1. So if you see in that way, what is this? d1 minus x1 plus 1, right? Before it was x1 square plus d1 minus x whole square. So you now you can try to see these things independently a bit. Like you can try to say something for this guy. See, for this guy you can say something, right? For this guy, you can move him as long as see, you have these two things now. See, it's all about writing the problem down and then it's done. I have made a comment on LinkedIn that writing the problem is not that easy. I don't know who that guy is, but then these people are thinking I'm trying to make a joke. I don't make jokes, right? I'm a very serious guy. I think the first part is quite difficult, like because the first part, this was what is this? Writing the problem, right? And then trying to move one thing from here to here. Then we can see this thing, the change. You see this change? What does this change means? See, it is x1 square plus d minus x square, right? x1 square, right? As long as x1 not equals to d1 by 2, moving this guy is beneficial, right? So now you have notes that are not yet beneficial, okay? Or not yet fulfilled, let's say. So like fulfill means if the splitage is very equal, then it's fulfilled, full fledged, let's say. Otherwise, it's not, let's say. So now you cannot have two nodes. You cannot have an edge. Okay, you cannot have an edge on two nodes that are fulfilled. Okay. No, no, no. Okay, you have fulfilled, right? Okay. And if they are not fulfilled, okay, in one graph they are bigger. Okay, you cannot have an edge on two bigger nodes. This you can say. If you have an edge on two bigger nodes, you move to there, this has reduced, that has reduced. You're good. So you cannot have an edge on two bigger nodes. This is one thing. So most of the things should be like this. Or you cannot have an edge on two bigger nodes, right? So either they both of them are equal. You have many equal things, or you have some things as bigger. Let's say this was bigger here, the other thing will be bigger here, and then you cannot have any more bigger nodes. See, you cannot have an edge on two bigger nodes. Means Means what? But then this doesn't say much. Should I go to E, or should I just end the stream? 12:42, right? It's too much. Maybe I'll do it tomorrow. I won't do. I have to sleep. I have to prioritize important things in life, right? It can be solvable, guys. Somehow it can be solvable. Maybe I will do good on round one. You guys can see then. Today I'm not doing. I'm sleeping. It can be done. Probably it can be done. Okay. It can probably be done somehow. Okay. Let me just solve this problem and then I'll sleep. Let me think some more time. If it's becoming bad, I'll try to sleep. If you have too big, then moving is definitely good. Okay. If you have one big and one small, then if you move this edge there, what would happen? This big guy might reduce. Is it possible to make everything small? Let's guess that. Is it possible to make everything small? Is it possible to make everyone's degree as this? Think of that. Is it possible to make everyone's degree as this? So you have a graph. You want to split half edges and half edges for everyone. For everyone, you have to do that. Can you do that? Always. How difficult is that? Why can't, if you can do that, let's think of a simple proof. I'm not able to see much here, right? So I'm coming back to guess. Can you always fulfill everyone into half half? Is this possible for a graph? Think of that. Why is this not possible? When is it possible? At least, because if it is possible, answer is zero. Answer is like the minimum, right? So we have to think about this problem. We must think about this problem. Okay, when can you split so that almost all degrees are even or equal? Okay, we have to think about this problem now. Okay, I think this is possible. Think of a cycle. Uh, think. Okay, it's possible as long as there's a cycle. Okay, if it's an odd cycle, see, if it's an even cycle, see, if it's an even cycle, then what can I do? Just think about this. If it's an even cycle, then I can make this one green, this one red, this one green, this one red, so that degrees doesn't change much. Okay, but if it is an odd cycle, we cannot change that well. If it is an odd cycle, you cannot apply the same logic of removing all the cycles, right? But now think of an odd component. Can you make, I have solved this problem already, guys. I have actually solved this problem already. I have solved this problem already. No, I have solved this problem already many times. Multiple times I have solved the same problem. I have solved the same problem, same idea in some 2700 problem here, but here it seems too much to use that much of an idea. But I have solved the same problem multiple times. I have even suggested this problem to some guy on our group, a Lokesh, or not Lokesh, someone else. Maybe 28, I don't know. Yeah. Here I have used the same idea, almost same idea. Like, okay, I'm not writing solutions here, that's bad, but then I stop. See, it's again same. I have to make all of them as one. See guys, do you guys get what I mean? As I solve many problems, bro. That's not much. I can solve any difficult problem. But then this is done. This is also simple implementation. So now my guess is, see, I was not able to prove anything here. So then I guess that this is always possible. We can always split into half off, is my guess. Okay, we can always split into almost half off, is my guess. You can always, I know this problem already. I know this problem already. I know this problem already. I think I know this problem already. Maybe I don't. Maybe I don't. The problem I know was you have a directed graph, you have a non undirected graph, you make them into directed edges so that things that come inside and go outside will be of equal length. But this problem is different. This problem is you have to make sure on everything number of green and red are equal, right? This problem is slightly different. How can we do that? Let's take the maximum degree vertex. Okay, you have to make these things half, right? You're taking the maximum degree vertex, you have to make these things half. Is it always possible to equally split the edges? Let's try to think some more time. Okay, is it somehow possible to split edges equally somehow? Okay, think of this thing here. What are we doing? We are doing green, red, red, so that it's almost equal for this, almost equal for this, but for this guy it's not equal. For this guy it can never be equal. Okay, so it's not being that easy then. For this guy these two things can, okay, then that guess is wrong. I'm sorry, because here all two two two, so the problem was different. The problem was making them directed and undirected. So maybe this problem will be much easier. Maybe this one would not be that difficult. You guys have to see properly. I thought it's about making them into directed and undirected edges so that everyone's in degree or out degree resultant will be less than or equals to 1 is the problem I have solved previously. But then this is, it seems similar. It seems similar, but then it's not now again. Okay, that seems similar, but then that's not this. This is not that. Hmm. Let's take this case itself. Here, here something will take two. We have one big thing. Okay, we have one big thing. Should I sleep then? It's not coming. Okay, that was one guess, but that's not working. That guess was you can always make them half, but then you cannot make here. Right? When it is 2 0 0, you cannot make 1 1 1. Like you cannot make 0 0 0. But what can we say? Can we say except for one for everything we can make? Okay, you have this thing for everything. Here it's odd number of edges, right? Odd number of edges. Is it possible if it is even number of edges? You have this edge that gives plus 1 to both or minus 1 to both. If you paint it red, it's minus 1 to both. You have odd number of edges. You have odd number of edges. But then it's not just about odd number. It's about the cycle too. Otherwise, we'll just paint green, right? Then this is plus 1. This is 0. This is 0. This is plus 1. It's about the cycle too that lets us not have this odd length cycle. Okay, remove all the even length cycles first. Okay, if you have even length cycles, then you can make them equal. At least that is there for us, right? If you have all cycles are even length, then you can attain the minimum. Why? You can use the same logic of this logic: red green red green red green. So for all bipartite graphs, you can make it the minimum possible. But now odd cycles, how can you deal with them? If I look at like this graph of bfs tree, let's say if I look at bfs tree, okay, all edges will be on tree edges, all non-tree edges will be among one same layer. Okay, bfs tree's properties, all non-tree edges will be among same layer. Is there a way to limit this to 2 at least? Like plus 1 minus 1, it will not exceed plus 2. Can we limit in that way? Our guess was it's either plus 1 or minus 1 or 0, right? The previous guess. Uh, Everything being the best. But here everything cannot be the best. But maybe there is some other greedy thing that would work. We don't know, right? Maybe some greedy will work always. We don't know. We have to think maybe properly on the problem. I'm not able to think today, guys. Bye. I'll end the stream. What is 07? Yeah, I'm ending the stream. Bye. Oh, sorry. How did I miss 07? I mean, okay, 07 is number, right? I thought of some other zeros. I know some Instagram page called 07 or 0. I was thinking about that. Okay, here if I alternate, let's say, okay, I will alternate here, but then you have in between edges, right? You have in between edges here. Can you again alternate among them? But then I don't get the alternate part here also. Okay, let's try to, if it is an odd cycle, let's just make it onto some vertex, let's just make it 2. And for everything else, let's just make it 0. Okay, if it is an odd vertex, let's only one thing will take it 2, let's say. Okay, so now as long as there are odd cycles, but what about if there are no cycles? Then what can you do? Let's think of a tree. If there are no cycles, then what's the answer? Like, see, before giving up, you have to think, okay, what about a tree? Can I solve it for a tree? What would be the answer for a tree? You have to think all these questions. Okay, so for a tree, I think we can always make them almost equal, right? Let's say you can make this almost equal always with either green or red. That's the assumption. With either green or red, you can make this almost equal, let's say. Now, then you will just choose few greens, few reds, make them almost equal. Now you again have the answer. If it is red, fix this as red. You will try to make them as almost equal, with red being more, green being less, red being less, green being more, because one red is always here, already here, and then you have answer. So you can, for tree it's always possible. For tree, minimum is always possible. Okay, for for this thing, for this thing, I think it's always possible to have this 2 on. Okay, less than or equals to 2 is always possible. Less than or equals to 2 is always possible. See, why less than or equals to 2 is always possible? You removed all even cycles. For odd cycles, let's say two odd cycles are containing this 2. Okay. Okay, you cannot have two odd cycles on this. If you have two odd cycles, you will combine them and then they will be even cycles, right? You cannot have two odd cycles on that. Okay, you cannot have two odd cycles on that. When once you remove all even cycles, let's say once you remove all even cycles, if you are having two odd cycles, means you can combine them to form an even cycle, right, on an edge. So odd cycles cannot, the final odd cycles you have after removing all such even cycles of edges or disjoint, you cannot have this thing getting merged with this thing. See how beautiful a bit it is. Now you have that. Now if there is something coming out of it, okay, now we have this odd cycle. Okay, you have this odd cycle. It's a tree of odd cycles now. Now if they have a leaf, if they have a connection, can you always neutralize that plus 2 with minus 1 is my question. That's what I'm trying to think of. Do you guys see what I'm trying to think here? If that odd cycle is connected to something else, we can neutralize that one. But then as it keeps going, you cannot always neutralize it. It somehow feels like a matching problem. You are taking it's like augmenting paths are being there, right? It somehow feels like a matching problem because of the augmenting paths and everything. And these are trees. We know for trees we can make them any color we want, right? For trees we can make them any color we want and they will all be equal. Now we can make any color for them equal. Now this thing goes alternate and then this thing will get fixed here. Once it gets fixed, whatever the color it gets fixed, you alternate that color. You make it, if two comes here, you make it one as the optimal, one as the big thing, and then you make it two one two. So seems except for except for one thing, I think you can make everything as almost equal. Seems that is possible. Seems what is possible is except for 1 2. I thought less than or equals to 2 is possible. Maybe except for 1 2, when there is an odd cycle, everything can be put at minimum. What do I mean by minimum? What is this 2? This is nothing but x1 minus d minus x1. The difference between these two, the gap between those two, it should be 0 or 1 is best, right? 0 or 1 is the best you can have. 1 is same as 0. Why? The sum is fixed, right? If it is odd, it is minus 1 and plus 1. If it is even, it is 0. Otherwise, it is 2 or 3. It's hurting. So, except 1, everything can be 2 is what my guess is. And is it true only for isolated odd cycle? After you remove all even cycles, because if it is not isolated, it seems you can somehow neutralize that too, right? If it is not isolated, it seems you can utilize that too. Somehow you can utilize that too. Why? Now it's like a tree, right? For the children, you can utilize it with either red or green. Because it's a tree, it seems possible. So, after you remove all the even cycles, where are we? It's not just that, it's like we are trying to see, we know this is a lower bound, right? This is a lower bound. So, I'm trying to think when that lower bound is achieved, was my first question. See, this was my first question. Why? After getting this, I need not think of this and then I can try to see. I tried seeing if there is something else. But then this question, we must think of this problem. Why? In all these cases, it's like zero, right? It's like the minimum possible. It's touching that lower bound. Because of that, I made a statement that we must think of this problem. Bro, is it care? You're ignoring what all I'm doing here. Like, I wrote a statement something like, we must think of this problem because this problem is crucial sometimes. And then you were like, okay, that can be true. What you told can be true, but that's not our whole strategy. Okay, our whole strategy is much different. I was trying to see if this problem must be thought of or not. So now I am thinking, okay, let's say it's also true that in this case also you can make them all equal, almost equal. Now you have an isolated uh, this thing. Okay, see if it is less than or equals to plus 1, you can always flip that. You can always flip colors and then it will become minus 1 or 0. Because of that, it's being possible always. You can flip this tree, subtree, and then you can choose whatever you want it to be. Okay, if so, because it's like a tree now, there are no cycles and there are only some odd cycles, disjoint odd cycles, because two odd cycles cannot combine. Then you will make it as an even cycle, right? So now, even here, if this odd cycle has something even, if this odd cycle has something even cycle along with that, because we removed even cycles, right? Then this doesn't help at all. Why? Even cycle, even if you flip them, one even comes, one even goes. So then you cannot help. This two. So these even cycles cannot help. But among this, they have some weight, right? They have some weight. Okay. Let's say in the odd cycle, in the isolated odd cycle, you have d comma d, 1 comma 1, like 2 comma 2, like this even things, like number of even things, whichever has the maximum even things. If you disrupt that, what happens? The square will become, so you have now d and 1 will become d plus 2 whole square. Okay, because you cannot save that, so you have to choose the minimum d. You will choose the minimum d and then you will make that thing as plus 2. Okay, the lower bound is that in this odd cycle at least one must have two. At least one must have two in this odd cycle. You cannot save it. You cannot save it at all. Okay, you cannot save that. At least one of them should have two. So this was our whole lower bound. This was our whole lower bound. And in this component, at least one of them must have two. Let's say this is having like 1 comma 1, 2 comma 2. Making this plus 2 is the minimum, right? The lower bound is that at least one of them should have two. That difference. Keeping it to the minimum thing is the best. So that's the answer, guys. I think. See, this is proof. That's why it's looking very complicated. This is ideas. The final solution may be simple. That's why you guys don't understand when you see solutions how to approach that. You don't understand it because we approach it by thinking a lot and then we come to some simple solution later. How to simplify this thing? I think this is the answer now. Why? This is a lower bound. At least one of them must have two. All other cases are minimum. And only this case, at least one of them should have two. What should have two? Something that's having minimum weight. You have to just make that two. D comma D plus 2. If you do D plus 2, the answer changes 4 plus 2D, right? So choose minimum D. This is the extra that you get by making that 2. So choose minimum D to do that. See, if the answer question was about, do you guys think my solution is correct? Three viewers. Pradeep Kya, do you think the solution is correct? Think of the solution. I have proved everything. I have proved everything, right? See, if there is an odd cycle, with everything being even, isolated odd cycle. Bro, it's not about approach, bro. The problem has been logically solved, right? Like, okay, thanks for being there. That's a lot. But see, if there is an odd cycle, isolated odd cycle, it can only have other even edges. Then at least one of them will differ by two, right? Differ by two means you try to split them, but then the difference will be two. At least one of them will become that, and that's a lower bound. And then we are fixing on that lower bound. We are making everything equal, and so that's a proof. For an isolated odd cycle, there is no way. Everything else is or like even edges, right? So if one implementation can be try to find cycle, try to find cycle, try to find cycle. You have all the cycles removed. Okay, you have all the cycles removed. If two cycles are having odd lengths on same vertex, you can remove those two too as an even length cycle. Okay, yeah, that's good. No, the thing is, DSU or not is the next question. Even I thought maybe DSU helps. I thought, uh, okay, let's say no, no, we have cycles. Yeah, that's fine. But then let's try to get a solution. Now let's try to get a solution. You have cycles. Now you have disjoint cycles. Okay, Now what will be left is, after combining all odd cycles, what will be left is, you either have isolated odd cycle, or you have an odd cycle that's not isolated, that's with some trees, or that has some other odd cycles. I'm telling, these things also can be made equal. I'm telling only this cannot be made equal, is my guess. Not guess, because but how do we implement this thing? Maybe there is a simple implementation, we don't know. Okay, my guess is here, you can you can flip these colors, and then you can make these things again equal by making this plus 2, this minus 1. So this will be plus 2, this will be minus 1, so the result will be plus 1. So all these also can be saved, only this cannot be saved. After you combine all odd cycles, so you remove all cycles. See, you remove all cycles. This can be done using Eulerian tools. Now, now you combine odd cycles if they share a vertex and remove them. Now you remove even cycles. Now you have disjoint odd cycles. As a tree and not isolated, we can make them equal, almost equal. But how we can see that? We should come up with an algo. Else we choose the minimum D vertex and make it take the plus 2. Let's try to work on the test cases for 1 minute, and we can see our ideas probably. Right, 1, 2, 4, 2, 2, 3, there are no cycles at all, it's just a tree. So all of them are almost equal, I guess. So we see, this is our problem. This can be done using Eulerian tools, finding all cycles can be done. Only this is our thing. But maybe we can use DFS on DFS tree and do the same thing. Right. Maybe we can do using just a DFS on DFS tree, and then we can do it maybe, because once a claim is true, doing that would not be that difficult. See, this is very similar to maximum matching. This thing seems very similar to maximum matching somehow, because we have these odd cycles in maximum matching. We have these augmented paths, right? Why is it similar to maximum matching? Because you have red. Okay, you have red, and then you make this green green, and then you make this red. Okay, and then you can go and then you can make this red, because green, green, green. Okay, this should be odd. Red, red, red. Yeah, and then green. So you can pair all of them. It seems you can pair all of them. You can always pair all of them, and then you can always pair all of them, and whatever you take, you will have. No, that's wrong because you can have many trees, right? But the trees can always be neutralized. Trees can always be neutralized, right? We know trees can always be neutralized. How can trees always be neutralized? You can make it either green or red, whatever favors you do that. How many solves does this one get? Like how many solves? Based on that, it might be easier. I don't think about many solves. Right. So that makes sense. That makes sense, right? Why the fuck you people haven't told me D is a difficult problem? Guys, why haven't you told me that D is a difficult problem? How this solution makes sense. Yeah. See, we got the solution, guys. Should I implement it? But you can see Pradeep Kaya that I'm able to solve much difficult problems effortlessly, right? Because I believed in golden rules, I went back and thought, is this enough? Is this enough was my question. And then it was enough. When was it not enough? Is a question that we can definitely think of. See, isolated odd cycle cannot be saved, right? You cannot save that. In that component, it's an isolated odd cycle, and you only have some even cycles, even edge cycles. So you cannot save that at all. So there should be plus two. You choose the minimum plus two for that. Here, all of them can be saved, but how to implement this thing? I think it has this difficulty. That's why only very less people have been able to implement it on correctly. Right. The next one is more easier with 35 points. But if they have kept it in D, maybe there is an easy solution. Oh, my diagrams are gone because I'm not using free version, right? The diagrams are gone. But still, can I implement it recursively somehow? It's like shrinking the odd cycles and then solving the problem and then expanding the odd cycles. So think of that. Shrink all the odd cycles into a node and solve it like a tree. Now expand odd cycles, okay? Because it's a tree, You can change colors of subtrees easily. And while you expand, you can choose a vertex to neutralize itself. See, okay, maybe it's true, but then this implementation is also not that easy, right? Like we don't know how to do that. Even after getting solution, it's being difficult. I can see that it's possible because it's tree. I can see that it's possible because it's tree, but then is there a simpler implementation somehow that makes all of them almost equal? Except these things, it should make everything almost equal. Maybe if I see DFS tree, can I do that? Can we even use even cycles? Let's say we have this even cycle. Can that even cycle help this? No, it cannot. It can never. Even cycle cannot help it. Right? If you make this GG, it will somewhere else form that. Even cycles cannot help. So this is perfect answer, guys. This is perfect answer. Even cycles cannot help. But wait. But even cycle can transfer the G to here. That makes it, it's not just minimum this D. Among this whole component, among this whole component, you have to take minimum D. Damn. Among this whole component, you have to take minimum D. But that's not difficult, right? That's not difficult. The difficult part is identifying a single odd cycle, identifying this, forming this odd cycles tree, disjoint odd cycle tree. Oh, can they be like this too? Maybe they will be like this too. And then you will shrink this, you have to shrink this, you have to shrink this, and then you have to solve the problem. Shrinking odd cycles is a very famous thing that's used in Edmund's blossom matching algorithm. Maybe people who have done that, people who have implemented that, maybe they were able to implement this, and maybe they were able to expand it back. And then if it is just one odd cycle finally, without any help, then maybe it's plus 2 will go to the Smallest even thing. Okay. After you shrink. But after you shrink, if you have this, you can make it plus one, you can make it minus one, and then you can adjust everything accordingly, taking this help. It's a difficult problem, guys. I'm ending it. Yeah. I think I have solved pretty much well. I won't try E. I'm sleeping. Bye. Good night.